again. Thanks for your patience. We had a just a small snafu with the laptop missing. I left it in the restaurant, and so we had to go back and get it. Thanks for your patience again. So just before we left, before lunch, what we basically looked at was the Kinect, what is inside the Kinect, the hardware, and what the SDK provides, right? So we basically saw that the SDK is really straightforward. There's only one class that we look at, which is runtime, and then from runtime, we can get access to all of the raw data streams from both the depth camera and the video camera. And we get all of these events that we can trap, that we can capture to get the data back. So let's get into code. The first thing I'm going to do is my Kinect is not connected, so I'm going to connect it first to this. I said you can get a separate cable to connect your device to the PC. Let's do that. And when that happens, you see that it's connected now. So one of the important things about the Kinect is it'll just show up in your device manager. You right-click Properties, Device Manager. And in here, you'll actually see the Kinect show up right under imaging. There it is, Microsoft Kinect. You basically see the Kinect device, the Kinect cameras, both the 3D and the VGA, and then the Kinect array control device, right, the microphone array. The important thing also is when you install the Kinect, it automatically gets installed in your Windows system as a default mic, right? And so that's the reason I was saying that you can use the Kinect with any of your applications that use the Windows, the speech API or the recording API, because at the end of the day, the Kinect microphone array is just another microphone that Windows by default recognizes. So that's a very good thing as well. So having looked at this, let's actually open up Visual Studio and build a Kinect application. Now, how many of you worked with Visual Studio in the past? Just a quick show of hands. Okay, so that's about half the audience. Okay, so that's great. So what we'll do now is, I'll walk through the process, and then certain steps, I'll sort of explain a little bit more for the few of us who have not used Visual Studio. But if you have any questions, please feel free to stop me and ask me so we can clarify it right there. In Visual Studio, what I'm going to do is I'm going to create a new project. Let's start from the beginning of it. I'm going to say new project, and I'm going to choose a Windows project, and I'm going to choose a WPF application, so Windows Presentation Foundation application. But you can use Kinect with any client project, which means you can use Kinect with Windows Forms application, you can use Kinect with XNA applications, with gaming applications, and so on and so forth. But for now, let's just choose WPF. And I'm going to call this Hello NTU, just as a name of the project. And when it opens up, it'll show me a blank template, a blank WPF application template. So this is the WPF application. How many of you have built WPF applications before? Okay, a few here and a few here. Okay, so in that case, I'm just going to take 2 seconds and explain the structure of a WPF application. What you're seeing here, this right here is the UI. This is the window where you set up the user interface elements. And the way you set that up is by using this markup language called XAML. It's like HTML, but it's a markup language. You use it to type, define the elements that you want on the screen. So for instance, I could come in and type things like button, right? And what it'll do is it'll create a button on the screen for me. It's just a really large button. Right, so you see it's a really large button called hello. I can do things like width equals 200 and then height equals 200. And then you see, basically by typing markup code, you create elements to show up. Alternatively, you can also use the toolbox and bring controls from here. So for instance, if I wanted another button from that I want to create from the toolbox, I'll just choose this button and double click it maybe, and then here's another button. And you can actually see the code that got generated here. It says button, content equals button, and height is whatever, and so on and so forth, right? So this is the markup, this is how you set up the UI. In terms of the code that gets executed, it's in this file called main.xaml.cs for C#, right? And this is the code that will run when the program actually runs. So if I wanted to do something, when I click my button, I will go in and choose one of the events of my button and then program against that event, right? So for button, I'll probably choose the click event, which you see is highlighted, it's selected by default as the default event handler. So I can double click on the click and Visual Studio will automatically create an event handler for me. In this case, it's calling it button_click, and any code that I type here will get executed when I click on the button, right? So as a simple example, if I type something like messagebox.show, and if I say something like hello world, and now if I run the application, my form will come up, it'll show me the buttons that I created, and then when I click on the button, it will say hello world, right? Really simple. So that's building WPF applications. It's really straightforward. It's just setting up your UI and then writing the code behind to execute when you do something on the UI. So in this case, the first thing I want to do is start using the Connect. So maybe what we want to initially start with is by reading the raw stream. So maybe we'll start by reading the video stream and then the depth camera stream right after that. So I'm going to delete all of this, and instead of a button, I'm going to bring in an image control. Right? The image control basically is used to display some image. If you look at the properties of an image, it exposes a property called source right here. And if you see what it is, it basically, the source property just takes some well-formed image. I'm just going to send it this file called ball.png. And it's just an image of a ball. And I'm going to say OK. And you'll see basically the image control displays my ball, right? So it's really straightforward. It takes an image and displays it on the screen. But what I want to do now is instead of having it display a static ball image, I wanted to read the stream from the video camera and then display it. So let's go ahead and do that. Like I said, the first thing we should do is we should start working with the runtime, right? Because runtime is the class that is used to represent the Connect. And if you want to start programming Connect, you start with creating a runtime object. So let's go do that. Let's go and say, let's create a new runtime. But first of all, this is not a Connect project yet. It's only a WPF application, right? So what we need to do is we need to add a reference to the Connect library, which, if you remember, is this file right here. So by adding a reference to this file, we can start programming the Connect in this application. So the way you add a reference is really simple. You come into the Solution Explorer, right-click on Reference, say Add Reference, and I know it's a .NET reference, so I can come in here. I'll see a lot of DLLs that I can add a reference to. The one that I'm looking for is called Microsoft.research.connect.dll. And so I'm just going to sort this by name and then search for Microsoft.research.connect. There it is. I'm going to say, choose this, say OK. And now what it's going to do is it's going to add it to my list of references in this project. Now I can basically, what that allows me to do is it allows me to now access all of these classes from within my project. It allows me, it brings in all of this functionality into my project. So the first thing I want to do is use the runtime class. So I'm going to create an instance of runtime. So I can basically say something like Microsoft.research.connect.nui.runtime. I can call it connect, right? But every time you don't want to be typing such a long name, so what I could do is I could take this whole thing and make it into a using statement. So now if I say using Microsoft.research.connect.nui, then I don't have to type the whole full name over and over again. I can just call it runtime and I'm good to go. The first thing we need to do is we have to create an instance of this runtime object, and if you look at the possible methods here, you see this method called initialize. We have to initialize it first. So let's go ahead and do that. Now, what I want to do is I want all of this initialization to happen as soon as my program launches, right? And so for that, you'll actually see that my main window exposes an event called loaded, right? So this is the event that gets fired as soon as your window gets loaded. And so we're going to use this event to basically instantiate our connect and initialize it. So basically what I'm going to say is connect equals runtime connects, runtime.connects, and then pass in 0. And this is how you do connect chaining actually. So if you have, say for instance, 3 connects connected to my PC, if I have 3 connects connected to my PC, I would basically choose which connect I'm initializing by choosing 0 or 1 or 2 here, right? Depending on how many connects you have, this connects collection will have that many elements. If you look at what this connects is, let me show you what it is. Runtime.connects is a collection, and it exposes a property called count, right? And so runtime.connects.count just basically exposes how many connects you have connected to your runtime. In fact, let's do that really quick. Before we write any line of code, I'm going to basically do this. I'm going to say message box.show runtime.connects.count.toString, right? We're not doing any button clicks anymore, so I'm going to delete this. So now what's going to happen is, as soon as my project gets loaded up, my window underscore loaded is going to execute, and the only thing that's going to execute from within is it's going to show me the count of the number of connects I have connected to my PC. So I'm going to run this, it loads up, I get this window that says 1, right? So it tells me I have 1 connect connected. Let me show you something else. Let me unplug this connect, right? Now I unplugged it. Now if I run it, it's going to come and say 0. Does that make sense? Right? It tells you the number of connects you have connected. All right, sweet. So I'm going to connect it back, and hopefully it's been detected. Now it says 1, so that's good. Okay, so and basically this is how you do connect chaining. You can find out how many connects you have connected, and then you can initialize all of that. So I know I have 1 connect, so what I'm going to do, I'm just going to initialize that. Connect equals runtime.connects, and just choose the first one. Choose the first one, right? Normally you would run it in a loop to initialize all the connects, but for now I'm just going to say I only have 1, so go with it. The next thing I have to do after creating or instantiating a connect is to initialize it, right? So I have to basically come in and say connect.initialize, and now you see that Visual Studio is telling us that initialize actually takes 1 parameter, right? And the parameter is of type runtime options. So what Visual Studio is smart enough to do is it knows that the parameter I'm going to pass in is of type runtime options, and so IntelliSense automatically highlights runtime options here. So all I have to do is press dot, and it'll tell me all the different properties in that runtime options enumeration, right? So at this point, I have to tell um, whether I want to use the color camera, right, which is this option, or I want to use the depth camera, or I want to use the depth camera and turn on player tracking, which I'll tell you in a few minutes what that is. Or finally, if I want to do skeletal tracking, right? What this is going to do, for now I'm just going to say .use color, close it. But what this is going to do is this. Let me show you really quickly. What that initialize statement does is when you call initialize in the API, it actually comes in and initializes, it actually sets up the driver chain in one of these subsystems, whether it is a subsystem for the video stream, whether it is a subsystem for the depth stream, or whether it's a subsystem for the skeletal tracking that comes up. So it basically initializes the driver subsystem, and that's basically what we're doing when we say connect.initialize. Now the next step, let me take you back into Reflector. So what we just did was we did the initialize. You see that there's also an uninitialize that we should make sure we call every time the program closes, right? So what we should do is when my program, main window, fires the closing event or the closed event, which means the program is shut down. And see, here's the closed event. Let's double click it. Here's my event handler that gets created for me. I'm just going to come in and say connect.uninitialize. And what this is going to do is it's going to do two things. It's going to release all of the resources that my Connect is using on my USB subsystem, and it will close the Connect driver stack. Right? So that's basically, this is how you start writing any Connect project. You basically instantiate your Connect, you write code to initialize your Connect with whatever option you need. For now, I'm just going to say use color, and then you remember to sort of uninitialize it when your program actually closes. So that's this is the whole initialization step of the Connect. Once you basically do the initialization, which is right here, we are free to basically at this point start using any of these streams, your video stream and your depth stream and so on and so forth. The first thing let's do is basically we want to read a stream from our video camera, so let's go start using that. I'm going to say connect.video stream dot, and these are all of the options that my video stream supports. If you want to use the .NET Reflector to find out all the options that video stream supports, come in here and just click on video stream, and you see that it basically is a type of something called image stream. So click on image stream, and these are all of the methods, and these are all of the properties that an image stream supports. So when you do the dot here, what you're seeing here is exactly these options right here. Right? So this is a good way to learn about an unfamiliar API when you're programming it for the first time. So use .NET Reflector and Visual Studio side by side to understand how all of it comes together. But if you look at all of the methods in image stream, you see that there's only 3 methods in fact. There's the get next frame. It seems like it's used to read a frame from the buffer. We'll get to that in a second. There's an option for get valid resolutions, right? And we'll get to that in a second as well. But it seems like this is the pertinent option right now, to open the stream, right? So let's go and do that. So I'm going to basically say connect.videostream.open, and now you basically see that it takes about 4 parameters. The first one is stream type. So I'm going to say dot, just to see what all the valid options are. And I see that there are 3 options: depth, invalid, and video. So this time I want to basically get the video stream from the RGB camera, so I'm going to say video. Then the next option is something called pool size. And I'll take a second and explain what pool size is. Inside the Connect, we saw that it has the cameras, right? But it also has a small amount of memory, right? So what happens is when the Connect actually reads data, it reads data and doesn't send it directly to your PC or to the Xbox. It reads the data and stores it in its memory buffer. There's a small memory buffer inside that the data then gets stored inside that memory buffer. And then the application, whether it's on the PC or the Xbox, reads the data from the memory buffer. right? It doesn't really read the data directly from the camera. Does that make sense? Right? It uses a shared memory mechanism where the camera writes the data to a memory, and then the PC program reads the data from the memory. They don't really talk directly, and it's a best practice because you don't. This way, you are able to do. You're able to get a huge advantage, which is multiple programs can actually access the memory at the same time, whereas only one program would be able to access the direct camera at a time, right? So because of the shared memory architecture, you can have multiple accesses happening at the memory. So what this value pool size is asking us is, it's asking us how many frames of memory should it allocate for storing the video frame buffer. So what I'm going to say is the option I'm going to choose is 2, and here's the reason why. If I choose only one memory frame, then there's a possibility of a reader-writer lock happening. So when the Connect is writing into that memory frame, my application cannot be reading from the frame at the same time, right? And when my application is reading it, Connect can't write to it at the same time. So you can basically create a contentional lock. So if you say 2 at least, then Connect would be writing into one frame, whereas you could be writing, reading from the other frame. So at least 2 is a good idea. You can go more than 2. The maximum limit is 4, but you really won't need to use 4 frames unless your PC is really slow or something like that. 2 is a safe number to go with in terms of allocating memory frame. Okay, the third option is where you denote the resolution of the image you want to retrieve from the camera, right? And it's an enumeration again of type image resolution. I'm going to say dot, and you can actually see that there's actually 1, 2, 3, 4 options where it's 1280 by 1024, 640 480, 320 by 240, and 80 by 60. Important thing to remember here is that the video camera, the RGB camera, returns resolutions of 1280 by 1024 and 640 by 480, whereas the depth camera returns a resolution of either 320 by 240 or 80 by 60. Right, so you have to sort of keep that in mind. I think the final version of the SDK when it launches will make it even more specific. I think we'll end up calling RGB resolution 1280 to 1024 and depth resolution 640 or 320, 240 and stuff like that. Right now it's a little confusing, but it seems like you can actually choose this to go with the video, but then when you run the program it'll error out because a video resolution can only be 640 by 480 or 1280 by 1024. So I'm going to choose 640 by 480. And then the final option that it's asking is something called image type. And if you look at the image type, it basically is just asking what is the format in which you want the image from the Connect sensor, right? The Connect sensor understands 2 formats for RGB. It understands the RGB format and understands the YUV format for color. But I'm just going to at this point say, give me straight color, which is going to return it in RGB format. So literally that's all the code for opening the RGB camera stream looks like, right? So all you're saying is, I want to open the RGB camera stream, and from there I'm expecting video and not depth data. I'm going to allocate 2 frames inside the Connect memory to store the frames as they keep coming in. Now, if you do not read the frame before a new frame becomes available, the old frames will just get deleted over and over. So basically, it's just going to get thrown out if you don't read it. And finally, you're basically saying, give it to me in resolution 640 by 480, and I want the RGB format instead of the YUV format. Any questions? Okay. So what's going to happen now, as soon as you execute this statement, what's going to happen now is the Connect RGB camera is going to start reading data from the scene in front of it. In fact, let me run the program now. Even though you don't really see anything happening, the Connect actually is reading data from the scene in front of it. Now, to actually get the data, what we need to do, because what's happening right now is it's reading the data, but it's only storing it into the local buffer. It's not really feeding it to us, right? So what we need to do to get the data from the buffer is, let's use this method called get next frame, which is going to go to the buffer and pull the next frame that's available from the buffer. So I'm going to come in and say, well, instead of doing it here, let me do this. Let me create a small button. There's a button like this. And let me bring it down here. And I'm going to double click this to get it to the event handler. And I'm going to now say connect.videostream dot read next. Okay, connect.videostream read or get next frame, wasn't it? Yeah, get next frame. And it's asking for one parameter, which is milliseconds wait. This basically refers to the amount of time in milliseconds that you want the Connect to wait if there is no data